Let's take everything we just said here and just put it into a nice definition box. So anytime we want to find relative extrema, the first thing we're going to do is determine critical numbers, right? That was the first thing that helped us get our answers here. So we figured out what were the critical numbers from the graph, and let's be able to do that without a graph. So we want to determine critical numbers by doing what we did on the first page. How do we find the critical number of x cubed? We took f prime. I'm going to set f prime of x equal to 0 or undefined. I want to make it 0 or undefined. And solve for x. So what that means is we want to figure out what x value makes it 0 or makes the denominator 0. Making the denominator 0 would make the derivative undefined, which is totally fine. That's going to help us find our critical numbers. Our next step is determine the sign of f prime to the left and right of each critical number, because we talked about these sign changes. So the first sign change is if the sign changes from blank to blank as we move across the critical number c, then we have a relative maximum. So what kind of sign change do we need for a relative maximum? Well, let's remember relative max look like this. So we want to go from increasing to decreasing across our critical number here. So let's write that in. We want to change from a positive derivative, change from increasing to decreasing, and that will always give us a relative maximum. Here we have the opposite. If we want f prime to change signs and be a relative minimum, then we want to look like a low point. So we're going to go from decreasing to increasing. So the other way around, we want to go from a negative first derivative to a positive first derivative. That will always yield a relative minimum. In the last case, if f prime does not change sign as we move across the critical number c, then f just does not have relative extremum at that value. So let's go back to f of x is x cubed and determine any relative extremum. So back to that page 35. And we did the first step already. We already found the critical number. X is 0. And we already made our sign chart and determined increasing versus decreasing. And then we want to figure out any relative extrema. Is there a relative max or min based upon our sign chart? So looking at our sign chart, we go from increasing to increasing. And remember, if there's no sign change, there's no extrema. We would need increasing to decreasing to be a max, or decreasing to increasing to be a min. So there is no relative extrema here just because we don't have any sign change. So we can flip back to page 37, and there were no relative extrema there. So let's look at the first example on this page. So we're given f of x is x cubed minus 3x squared minus 24x plus 92. We want to determine the critical numbers, relative extrema, and where the function's increasing or decreasing. So I'm going to do my same two steps as before. I'm going to take the derivative and set it equal to 0. And so my derivative is 3x squared minus 6x minus 24. I'm going to take that derivative and set it equal to 0. So this is a tough one to solve for x. I'm going to solve for x by factoring. I have a trinomial, something with 3 terms, and I can pull out a greatest common factor here. I'm going to pull out a 3. I'm going to have 3 times x squared minus 2x minus 8 equals 0. I can factor this some more by doing some reverse foiling. So I want to figure out numbers that multiply to be a negative 8. So I must have a positive times a negative. But they have to add up to be negative 2. So I'm going to say a -4 and a +2 will multiply to be a -8. So I want to figure out what makes this 0. And I'm looking at my first factor is 3. I can't ever make 3 0, so that doesn't give me any critical numbers. But if I look at my next factor, what would make x plus 2 0 is if x was -2. And what would make x minus 4 0 is if x was 4. So I can always try to set each factor to be 0, but this I don't get anything. 3 is always 3. But now I have 2 critical numbers, and I can actually throw those in right here. Here's part of my answer. My 2 critical numbers, I have 2 values that make the first derivative 0. They are -2 and a +4. And now I can make my sign chart to find the rest of the information. Relative extremum, increasing, decreasing is all going to come from my sign chart here. So I'm going to put my critical numbers in. My critical numbers are at -2 would be my first one. And over at +4 would be my other one. So if I plug into my derivative here, I just need to choose some random test values. Sometimes it works best to just label these critical numbers. These make f prime 0 so that we don't forget these are special. These are the only places where relative extrema can occur. So it won't happen at a test value. And these are only numbers that are going to be in the intervals of increasing and decreasing, not our random test values. I can choose anything I want. So maybe to the left of -2, I'm going to say -10 is to the left of -2, and we always plug into the derivative on our sign chart. So I'm going to plug in here, and I don't care about the number I get, I care about whether it's positive or negative. So I'm going to plug in, and 3 is always going to be 3 for my first factor, so my first factor is always positive. Then I'm going to do -10 plus 2, which is going to be some negative number. And then -10 minus 4 is definitely going to be a negative number as well. So I have a negative times a negative and a positive. So this ends up being a positive times a positive. This interval is going to be positive. The function must have been increasing before -2. Between -2 and 4, this is my favorite interval because I can choose 0 for a test value. That's always nice. So I'm going to plug in 0 into the derivative. So I'm going to have 3 as my first factor, which is a positive number. And I have 0 plus 2, which is positive, and 0 minus 4, which is negative. So I end up with a positive times a positive, which is positive. But then I multiply it by a negative, and that's going to make this interval negative. So it must be decreasing. So my other one was increasing, and I switch over to having a decreasing interval. So I'm going from increasing to decreasing. This is certainly going to look like a relative max. Increasing to decreasing. So I figured out what my first critical number is. And now my next critical number could either be a relative max, min, or neither if I don't have any sign change. I can choose any test value on this interval, so maybe I'll choose a +10, and I'm plugging into my derivative. So I'm going to plug into 3, which is always a positive number. And then I have 10 plus 2, which is positive. And then I have 10 minus 4, which is positive. So all these positives are definitely going to multiply together to be positive. So this interval is going to be increasing. So I go from decreasing and switch to being increasing. This is a relative min. So I'm going to fill out what I know so far. So I'm increasing before -2. So negative infinity to -2 union. I'm also increasing 4 to infinity. So notice only your critical numbers go in your answers down here. I don't switch up my test values. And then I'm decreasing between my 2 critical numbers, -2 and 4. And last piece, I want to identify these points. My relative max is at -2. And to find the y value there, I just need to plug into the original function for the first time. So if you plug back into the original function, you get 120. And again, this comes in Make ourselves a note so that we remember this is the only time we go back and actually plug into the original function, f of 2. Our relative min is at our other critical number, which was 4, not at a random test value. And I'm going to plug into the original function and see that the y value there is 12. And again, that comes back from plugging in way up top at that original f of 4. And I plug in up here, I get 12 out.